back to Serah's computer session. So this video is actually the continuation of my last updated video. So if you're sitting with me now, I hope that you have clearly understood what I have taken in my last video. If not, please go to the last video, watch it in full, understand it, and then come and watch this video. Okay, so here in this video I will be explaining how data is stored in memory, because that is really important while you study data types. So let's move on to the video and see what I have for you today. In order to understand these data types clearly, like the amount of memory that has been assigned to different data types, as well as like the range of values that is associated with each data type, in order to understand everything like these stuffs, you have to first understand how the data is getting stored inside the memory. Okay, then only you will be able to study data types properly with the proper logic. So let's see how data is stored in memory. See, memory can be considered as a large register. What do you mean by register? You might have seen registers like office registers, different registers are there, attendance registers are there, leave register is there, a lot of registers like accounts register. You know why registers are used. Why are registers used? Registers are used to store information. So if memory is considered as a large register, obviously memory also stores information. When you enter a data, this data is getting stored inside the memory, right? So when the data is stored, or before the data is stored, the data is actually converted into its corresponding machine code, or you can say that binary, corresponding binary number or binary data before it gets stored into the memory. Why? Because a computer understands only machine language. So since the data is being converted to binary, the data that will be stored inside the memory will be comprising only of 0 and 1. They will only be comprised of zeros and ones. So what are 0 and 1? Well, what is 0? What is 1? They are binary digits, or else we can say that they are bits. So what is bit then? Bit is the fundamental unit of computer memory. If suppose we are allocating a certain amount of memory, say for a data, we can say that certain amount of bits are allocated to that data. Okay, so bit one single bit can take either of two values, and they are 0 and 1, 0 or 1. So it actually acts as a switch, like the switch for a light, a switch for a fan comprises only two states, off or on, off or on. There are no other values that a switch can hold. Likewise, a bit can either hold 0 or 1. Okay, so then what is byte? Byte is the next larger unit of memory, and one byte is actually a collection of 8 bits. When you consider a collection of 8 bits, you can say that it is one single byte. Then we should understand what a word is. Word is a collection of 4 bytes, not bits, it's 4 bytes. So if 1 byte is equal to 8 bit, then 4 bytes will be equal to 4 into 8 bits. Simple mathematics, right? So you will get 32 bits, and this 32 bits is considered as one word. Okay, now you should understand what a word size is. It is the preferred size for moving data around with respect to a particular machine. I had explained what processor speed is, right, in the previous slide, in the previous video I had explained about the processor speed. So processor speed actually depends on the word size. What is the word size that the processor takes in at a particular time? So you have to understand all these 4 concepts clearly in order to move further. Now, if one bit can represent 2 values, say 0 and 1. Okay, let's write this in the power of 2. It will be 2 raised to 1. Why are we actually taking power of 2? See, in the decimal number system that we usually use daily, it is actually a base 10, right? But since all the calculations relating to computer systems are binary calculations, we usually use the power of 2 because binary means it is 2, right? So one bit can represent two values. One bit can store only one value at a time, but a total of two values can be represented using one bit, and that is nothing but 2 raised to 1. So then 2 bits can represent how many values? Let's see. Okay, these are the 2 bits, and since a computer takes only 0 and 1, we can use only 0 and 1 for the purpose of generating numbers. So suppose you are given 2 bits, how many numbers can you generate using 2 bits, or how many combinations of these 2 bits can be taken? Let's see. The first combination is using 0 and 0. The next one is you can just use 0 and 1. Just you can change the 0 of the last significant bit and change it to 1. You will get another new number. Okay, the next number is 1 0, and the next number is 1 1. Okay, I believe that only these 4 different unique numbers can be generated using 2 bit, right? So 2 bit can generate 4 values, and they are 0 0 0 1 1 0 and 1 1. So since it can generate 4 values, when we take power of 2, it can be written as 2 raised to 2, because 2 raised to 2 is equal to 4, right? So here actually the 0 0 0 1 1 0 1 1, they actually represent numbers from 0 to 3. Now if you are a person who knows the binary to decimal, decimal to binary conversions and all, you will be understanding this concept better. I don't have time to explain those conversions here, and therefore I'm not explaining it. If you need conversions from my part, you can leave a comment so that I will be able to help you out with the conversions. Okay, but you don't actually have to study the conversions in order to calculate this. See, if 3 bit can, if we use 3, if 3 bit has been allocated for a data, how many values can the 3 bit hold? That is what we are actually looking into from this slide. The value, the 3 bits can hold 8 values, and it is nothing but 2 raised to 3. Okay, so here you see the bit. Okay, how many bits? If it is n bit, that n bit is can generate 2 raised to n values. See, the power, the superscript is actually n, or for 1 bit it can represent 2 values, means the value 1 appears at the as the superscript of 2. It is the power. So you don't actually have to study the conversion in order to understand this concept. Just understand that if you are given n bits to store a data, then with the n bits you can actually generate 2 raised to n values. Okay, so n bit can generate 2 raised to n values. If your machine allows n bit for a data type to be stored in its memory, then this n bits in memory can hold any one of the values from a total of 2 raised to n values. Okay, I hope you understood my point. See, you have n bits at hand. You can generate 2 raised to n values. Okay. Now, when you input a data, care should be taken that the data is actually one among the 2 raised to n values that can be generated. If your data is not one among the 2 raised to n values that can be generated, then you will not be able to store that data in that variable that is provided or in that space that is provided for you. Okay, so there is a range of values. Limits are there. A minimum and a maximum value are there that this n bits can hold. And your data should be coming within the limit that will be actually permitted for that particular data type. Now let's see an example. You will understand it better. If suppose n bit, the n value of n is 2, 2 bits in memory can hold any one value from a total of 2 raised to 2 values. If you are given 2 bits, you can generate 2 raised to 2 values, right? So if you are plotting those values in the number line, you can see that the values are 0, 1, 2 and 3. If you are able to generate 4 values means, right, starting from 0, it will be 0, 1, 2 and 3. I am not considering negative values here. Only positive values are considered here. Okay. So these are the 4 values that can be generated using n bits or 2 bits. Okay. So what will be the minimum value? From the number line you can understand that the minimum value is 0. And what is the maximum value here in this example? It is 3. Now how will you obtain 3 using the values 2 and 2 raised to 2, because these are the only values you are known, you know about, like n value of n is 2 and you can use the power 2 raised to 2. So from these two values, how will you obtain the value 3, the maximum limit? How will you obtain the value 3? It is 2 raised to 2 minus 1. 2 raised to 2 is 4. 4 minus 1, you get 3. Now see, the upper limit is 3 because we have started from 0. If you had started from 1, the upper limit would have been 4. Okay, but most of the computer calculations start from 0. So that's why we are always taking numbers from starting from 0. So since it ends at 3, you have to obtain 3, and you can obtain 3 using 2 raised to 2 minus 1. Okay, now let's take another example where value of n is 3. So 3 bits in memory can hold any one value from a total of 2 raised to 3 values. Okay, so let's draw the number line and chart out the different values, the 2 raised to 3 values. 2 raised to 3 is equal to 8. I hope you know the power calculations. 8. So since you get 8 values, and since the value starts from 7, the last value will, starts from 0, the last value will be 7. So here also, since we are considering only positive values, the minimum value is 0 and the maximum value will be 7. How can you obtain 7? It is 2 raised to 3 minus 1, right? So minimum value is 0 and the maximum value is 2 raised to n minus 1. If we generalize and form an equation for calculating the minimum and maximum value is 0. I don't think that you need an equation for that. But for maximum value, you can say that the equation is 2 raised to n minus 1. What is the value of n? You substitute that for the power value and you will get the maximum value. Okay. Now let's look when what change happens when we consider negative numbers also, because in data there can happen situations can happen where we have to enter negative values. So what change will happen if n bits, the value of n is 2? Clearly 2 bits in memory can hold any one value from a total of 2 raised to 2 values. Now what is 2 raised to 2? We know that it is 4. So if you have 4 values, it should be equally distributed among positive and negative values. That means 2 values for positive and 2 values for negative. 2 values for negative and 2 values for positive. Now, if I am going to draw a number line and chart the numbers starting from 0, let's start out the negative numbers first. Two values means what all values will be there for the negative number. It will be -1 and -2. Then for positive value, it will be 1 and it will be only 0 and 1. See, for positive numbers, there can be only two values. So since we are considering 0, only 0 and 1 can be generated using uh, 2 bits when we are considering negative numbers also. Okay, I hope you understood this. So these are the four numbers generated, and -1 and -2 are the negative numbers, and 0 and 1 are the positive numbers. Now let's look at the range. How can we calculate the minimum and the maximum range when we consider negative numbers also? Range of data type values when negative values are included. Look at the number line. Here, for this particular example where the value of n is 2, we have a minimum value as -2, right? The minimum value is -2. How will we obtain this -2? We only have two values at hand, and that one is the value of n, and the next one is the power value, and that is 2 raised to 2. 2 raised to 2 is 4, right? So how will we obtain this minimum value? 2 raised to 2. 2 raised to 2 minus 1. See, 2 minus 1 comes as the superscript. So 2 minus 1 is 1, right? So this will be actually 2 raised to 1. So if you actually attach a negative value to this calculation, you will get -2. Now, how will you calculate the maximum value? Here, the maximum value is 1, right? So, how you will get the maximum value? 2 raised to 2 minus 1, minus 1. Right? 2 raised to 2 minus 1, you will get 2. And 2 minus 1, you will get 1. So, when we generalize the min-max calculations into formula, we will get the equation for calculating minimum value as -2 raised to n minus 1 and maximum value as 2 raised to n minus 1 minus 1. Let's look at another example where the value of n is 3. 3 bits in memory can hold any one value from a total of 2 raised to 3 values. So what is 2 raised to 3? It's 8, right? So let's draw the number line. Here we are considering negative numbers also. So 8, when you equally divide 8 into half, you'll get 4 and 4. So 4 values from the negative side and 4 values from the positive side can be considered as the permissible set of values for 3 bits. So 4 values for negative and 4 values for positive. So plotting the number line, you will get positive numbers as 0, 1, 2 and 3, 4 numbers, and negative numbers as -1, -2, -3 and -4. So these are the numbers obtained where you can see the negative portion as well as the positive portion. Now let's see how the range will be calculated. Okay, now minimum value from the number line, you can see that it is -4. So how will you get -4 from the values that you have, and that is n equal to 3 and 2 raised to 3. From the last example, if you are comparing with the last example, what was the method used? 2 raised to n minus 1 and putting a minus sign in front, right? So 2 raised to 3, 2 raised to 3 minus 1. What is 3 minus 1? It is 2. So 2 raised to 2 and putting a minus sign, you will get 4. Now calculating maximum value. I hope that I'm not confusing you. If you're getting confused, please pause the video and do calculations on your own with the paper and pen, and then you can resume my lecture. Okay. Now maximum value here, from the number line you can see that the maximum value is 3. So how you will get 3? It's 2 raised to 3 minus 1 minus 1. 3 minus 1 you get 2. So 2 raised to 2 is 4. 4 minus 1 you will get 3. So again, generalizing, you can see that the same equation comes up. For minimum value you will get minus 2 raised to n minus 1, and for maximum value you will get 2 raised to n minus 1 minus 1. Now these are the primitive data types that we had seen in our last video, and they are char, int, float, double and void. I will be giving detailed explanations on this data type in my next video. Hello, I hope all of you have understood what I explained today in this video. So we actually learned about how data can be saved inside memory, right? If you are given n bits, how many values can be actually generated, and the limit associated with the values. I hope that this is really useful for you, because if you only if you understand this video as well as the previous one, you will be able to clearly get through the data types in C. So in the next video, I will be dealing with the number of bits allocated and the range of values for C data types. So please like, share and subscribe to my channel. I hope to see your comments as well as your feedback. So please do support me, and we'll be coming with the next video very soon. So thank you for watching, and God bless you.